All right, where do you want me to start?
39 and then 42 through 48.
39 and then 42 through 48.
You have something on your back.
Wait, turn around, I want to see.
Turn around. Turn around. Turn around.
Something honest.
Your girls are delicious. It's 39. Oh, it was. I wrote it down.
Okay, so we're taking the derivative, right?
I didn't know if I could change. Okay, that's
Yeah,
what you
so you
did.
change the square root to exponent, okay? And then you just do the power rule and the chain rule. So I'm going to take the exponent and put it in front. So that makes 1/2 times everything in here stays the same. To the negative 1/2, because we're subtracting now, because we're doing derivatives again. And then I have to multiply that by the stuff in the derivative of the stuff inside the parentheses, which is,
Did you leave the 2 there?
I'm going to multiply it together with the 3. Yeah, I'm going to go 6e to the 3x. Because the derivative of e to the 3x is e to the 3x times 3. And I had a 2 out there already, so 2 times 3 makes 6.
So we have to multiply by the derivative of the exponent.
I did, that's why this is 6 and not 2. Okay? So I did this derivative, I did this derivative, and I did this derivative, so there's nothing left in
You
the
could simplify.
I could simplify, yes.
Don't do
I could rewrite this as 6e to the 3x over 2 times the square root of 1 plus 2e to the 3x.
Or you did the 3 into the.
Oh, yeah, you're right. This 2 and this 6 can reduce to 3. Good call.
Look, it's you.
Yes.
What? Let me see.
What am I doing now?
You look
Which one? Which one?
That's 42 through 48.
42 to the end.
That's weird.
You don't have to simplify when
Sure, I'm good with that. All right, so now we're doing quotient rule. So that is low. So we're going to leave it as e to the u plus e to the negative u. D high. How
No,
about
because
e? Whoops. How about
And
e
then
to the u?
it's plus.
Right. Plus e to the negative u. Because the derivative of this just stays as what it is. But then I have to multiply by the derivative of the exponent, which is negative 1, so that's going to come and combine with this negative to make it positive.
So are the e's just constants?
Yes, e is a constant, yeah. All right, so low d high minus high d low. So what's the derivative of the low term? That same thing, but it's minus. Good. E to the u minus e to the negative u. Over, I did that right here,
Oh,
so maybe
shoot.
it's my fault. Over the
I
square
mean, the square was
of
below.
what's below. Okay, that is good, but we're going to simplify the top just for fun. So you don't have, you can let this go, okay? But some fun things happen with these e terms that you should be aware of. Okay? There's going to be a lot of canceling, yeah. So if I FOIL this out, first times first, what's e to the u times e to the u? E to the 2u, because you add the exponents together. Okay? Outside times outside, what is e to the u times e to the negative u? What's that? Oh, okay, I can give another one to you.
Yeah, just whenever you.
Okay, all right, remind me next period. Oh, like now?
Yeah, once you have them all out, do you want me to
Okay.
show them?
Yeah, just hang out there and then let me finish the following. Okay, so if I go e to the u times e to the negative u, what do I get?
E to the negative 2u.
What?
E to
This is why we have to do
Even
this
the
problem.
to the zero.
E to the 0, good, because you add the exponent, so u plus negative u is 0, so that's just going to be 1, okay? Anything to the 0 power is just 1. So same thing with the inside term, e to the negative u times e to the u is also going to be 1. And then last times last is e to the negative 2u, okay? 2u. Right, and then we're basically going to get the same thing when we go here. First times first is going to be e to the 2u. Outside together is going to be this time minus 1. Inside together is also minus 1. And last times last is plus e to the negative 2u. Okay? So the reason why this is fun is because this e to the 2u and this e to the 2u cancel. This e to the negative 2u and this e to the negative 2u will cancel. And then 1 plus 1 minus 1 is going to be 4. So final answer 4 over e to the u plus e to the negative u squared. Okay?
As cool as that is.
Cool, that is, you're over it.
I appreciate it.
What do we got going here? You don't like when they use letters as constants? That's understandable. How am I going to solve this?
The same way you roll.
Same way you did the other one, quotient rule. So I'm going to go low, b high, and then that's the big question. What's the derivative of a e to the x plus b?
E to the F.
And
A e to the x.
Is it not like a number?
Yeah, but it's being multiplied by it, so you keep it there. It's like if you did the derivative of 3x squared, it would be 6x, right? 3 doesn't do
Why don't you have to
show what?
Okay, so it's a to the x, and a is a constant, would it be x a to e to the x minus 1? No, the substitution.
Oh, you were gone.
Oh, so that is just.
The derivative of e to the x is e to the x. That's what we're going down. Okay, so low d high minus high d low. What's the derivative of the bottom one? C times e to the x over the square of what's below. Okay? We do have a little bit of canceling here that we can do. If I go c e to the x times a e to the x, and then here I have the same thing, c e to the x times a e to the x, and that's a minus, so those will cancel, right? So this will leave me with a b e to the x minus a c, b c e to the x all over that.
It was great this morning. I woke up and cleaned my room and then took a nap. And then I rewarded myself for cleaning my room.
You rewarded yourself, yes.
I just woke up and then I laid in bed for an hour.
Actually,
All right, 44,
So,
same thing as 39, except that the derivative of the stuff inside is going to be a little bit more complex, because to take the derivative of this, I need to use the product rule. Okay? So first I do the power rule, which is easy. Put the 1/2 in front. Leave the stuff inside alone. And then subtract 1 from the exponent. So then I need to multiply that, I could, by the derivative of the stuff inside the parentheses. Right, the derivative of 1 is 0, so nobody cares about that, but the derivative of x times e to the negative 2x, since the x comes up twice, we have to use the product rule for that, okay? So first one times the derivative of the second one. What's the derivative of e to the negative 2x? Negative 2 e to the negative 2x. Everything stays the same.
Oh, that's right.
Yeah, e to the x is its own derivative. So that was the first one times the derivative of the second one, plus
Plus just e to the negative
the second one, e to the negative 2x times the derivative of the first one, and the derivative of x is just 1. All right? That one I'm not going to touch. I'm just
Wait, but can you, because we have to, oh no, right, we have to multiply the x in it.
Yeah, I don't know. There might be something in there, but I'm totally not worth it. Now they throw cosine in.
Could it be?
Then you just do the.
Yeah,
With the change.
no big deal. Okay, so all the cosine does is when we take the first derivative, the derivative of cosine is negative sine, and the stuff inside the parentheses stays the same. So you're going to start with negative sine of 1 minus e to the 2x over 1 plus e to the 2x. So that's no big deal, right? It's when we do the chain rule, so now we have to find the derivative of this stuff right here. The things get a little bit ugly. So I'm going to go low, b high. What's the derivative of 1 minus e to the 2x? Good. Negative 2e to the 2x. Minus, so we did low d high minus high, which is 1 minus e to the 2x. Below, what's the derivative of 1 plus? Okay.
This isn't big deal, I think it is.
Over the square of what's zero.
We're not,
Do you want to be done?
Well, I think
Just
we
a little
answered
bit.
like that
You-
on the, calculus that you
Yeah, the only problem you would run into if you had a problem like this on the AP calculus test is if it just said this, you're okay.
Is it simplified?
There's two things. One way is that they could give you answers as multiple choice, and the multiple choice answers could be the simplified versions. And the other thing that can happen is you might have to do some math with this answer, like 7
Okay,
equals
let's
0,
simplify.
in which case you'd have to simplify. So let's simplify it. What the heck?
Why you're getting paid the big bucks.
That's right.
Ends up by 1 with 2.5.
Okay, so we've got to finish one more column, and then hopefully we can catch the last minute of that game. All right, so this isn't that bad. All I have to do is distribute this. 1 times negative 2 e to the 2x is negative 2 e to the 2x, right? And then e to the 2x times negative 2 to the ex is what? What do you do with the exponents? Add them together, good. So that would be negative 2e to the 4x minus, same deal here, if I distribute this, 1 times 2e to the 2x is just 2e to the 2x. And then negative e to the 2x times 2e to the 2x is negative 2e to the 4x. And that's all over 1 plus e to the 2x. Great. Okay, so once again, we get a little bit of canceling. This negative 2e to the 4x and this negative 2e to the 4x will cancel. And then those combine to make negative 4e to the 2x. Times the other one. I don't want to do that. So, that's no, I can't wait because we're going to miss the game.
Why don't the other two?
Why
Oh
don't
no, because that means.
because we're subtracting, right?
You have to simplify it.
Hey, game.
That's what we
How's it
just
going?
did.
You know, but that, I mean, it doesn't come out to a number at all?
Well, you could combine these into negative 4e to the 2x. And that's what you should write as your final answer, but I don't want to write it out because yours not game. All right, last one.
Wait,
That's a game.
You got one more, we can do it.
Who asked? Yeah.
Actually, we went to 48.
Ends up by 3.
Okay, this is a little bit of a beast.
Yeah.
Since this squared right here is not in this stuff, but it's with the sign, what that actually means is, right, sine of all this stuff squared. So the first thing we have to do actually is the power rule. So I'm going to put the 2 down in front, and I'm going to leave all that
What was
stuff
that?
below. And then if I subtract 1 from the exponent, I just get 1, right? So that's the derivative of the exponent. What derivative do I do next? Well, the derivative of sine is cosine, and leave this stuff alone. So e to the sine squared t. Okay, what derivative do I do next?
Oh, you're multiplying all of that?
Yeah. Right, now I
Wait,
need
why
to do the
did you
derivative
cancel?
of the e, and that's going to be e to the sine squared t. And then I have to do the derivative of sine squared t, and so I have to do the power first. So it's 2 times the sine of t, and I have to multiply that by the derivative of the sine itself, and that would be cosine of t.
Is it negative?
Okay? No, derivative of sine is positive cosine.
Great.
Okay?
That's great.
Yeah, so that is a total, no, not simplifying,
Minus cosine t?
times. So that's a train wreck.
Yeah.
Okay, so same as number 47, we're going to take the derivative. So how do you take the derivative? Loading high, so x times e to the x minus I below e to the x over x squared.
And then what do you plug in?
You plug in 1, you always plug in the x squared. Yep, so that would be e minus e over 1, which is decimal. 0 over anything is 0, except for 0. Then you got to do. There's 2 notes in it. You are right. So you win. You go top to the 0 on the bottom. Anyway, so then you can go y minus e equals the slope times x minus 1. So that would be y equals c. So the slope is 0, so it's a horizontal line going through this point. Okay? What are we down here? 35. Okay. Did we finish this section yesterday? Oh, we didn't do, okay.
Fifth grade 1.216. And then 1.5.
42,
Mr. Aldridge, did you make a bracket?
Obi has a sound.
I did, but I don't know if it's saved. He said
Did
it
you
didn't
have
save,
all your
and I
math
tried
classes
again.
make a bracket?
Okay, so I'm going to give you 10 more going the other way, because what we know is if the derivative of e to the x is e to the x, then the antiderivative of e to the x is also e to the x. And so you can do some integrals. Do that, okay?
I think you're gonna place it.
Well, I was looking at the weatherchannel.com.